Welcome to my first video. Today I'm going to show you how to solve a word problem that deals with the intersection of three circles using simultaneous solutions in systems of equations. Just to give you a little background on the problem, this is actually one of the questions I gave during the midterm examinations in pre-calculus. I'd rate it as a medium level problem because of the number of times we will have to repeat simultaneous solutions to get our answers. But there are other ways to tackle this problem if your teacher allows you to use graphic calculators. So let's dive into this problem. The police are triangulating the location of a known criminal using his cell phone. It was determined that when the suspect would make a call, 3 cell sites with descriptions listed below would receive the signal. Identify the location of the suspect. As we analyze the problem, we will assume that the data given pertains to 3 circles whose centers are not located at the origin. We can make this assumption because the problem and table does not hint about any foci, vertex, or axis. Another consideration we can make is that we will have to understand that the directions pointed north and east will be written as positive values. The directions pointed west and south will be negative values. Remember, if you need more time to study my work, don't hesitate to pause the video for your review. So we begin by substituting the location of each tower into the standard equation of a circle. The distances given will serve as a center point for each circle, and the range for each tower will become the radius. For the first tower, the equation becomes open quantity x minus 7 close quantity squared plus open quantity y minus 3 close quantity squared equals to 2.2361 close quantity squared. We then proceed to square the value of the radius, making the right hand of the equation equal to 5. Now repeat the same process for towers 2 and 3. You may pause the video to check how the substitutions are done. Having set up the given and equations, it's time for us to take a little pause to plan out how we're going to tackle the problem. First, I'm going to get the general form of each equation by expanding it to binomials to make it easier for me to remove the terms. Next, I plan to combine all 3 equations to form a single expression that will describe the common point of all 3 circles. This is where things might get messy. Lastly, I'm going to take the results of the common expression and substitute it into the working function to find the missing value. Let's execute that plan. I'm going to expand both binomials in the standard equation for tower 1. You may use the FOIL method as presented here, or you may want to use other techniques like the Punnett square. Use whichever method you find more comfortable for you. The resulting expression then becomes open quantity x squared minus 14x plus 49 close quantity plus open quantity y squared minus 6y plus 9 close quantity equals to 5. Next, I'm going to remove the parentheses that have been grouping the differences along both axes. Don't forget to properly distribute any operation found adjacent to the parentheses. We then combine similar terms as they appear. By this point, most math teachers will tell you to transpose the value from the right-hand side of the equation to the left-hand side. But let me just give you a reminder that transposition is a shortcut, and it should be done correctly. We add or subtract an inverse identical value to both sides of the equation to maintain the equality of the function. Remember, what you do to one side of the equation, you do to the other. Finally, we arrange the results such that our expression is similar to that of the general form of conic figures. Pause the video here to try to find out for yourself with equations 2 and 3. If you get the same answer I have, feel free to smash that like button. Moving on, it's time to start the second part of our plan that aims to remove the terms whose literal coefficients are squared. First, we multiply each equation with a multiplier that will make the products cancelable. So, if I double the first equation, then I take the inverse of the second and third equation. Next, I add all the expressions together. I can create a sum for the x squared term and the y squared term that is equivalent to 0. This is what I mean by simultaneous solutions, to change the certain number of equations at the same time. The resulting process gives us a fourth equation that reads as negative 12x minus 6y plus 72 equals to 0. Pause the video again and try this on your own using equations number 2 and 3. If you get the expression negative 4x plus 10y equals to 0, good job, and don't forget to smash that like button. We're in the home stretch part of our plan. I'm going to simultaneously solve equations number 4 and 5. This time, my goal is to remove the term with the y variable. That gives me an expression of negative 144x plus 720 equals to 0. Next, I'm going to transpose all the known terms to the right-hand side of our equation, leaving the terms with the x variable on the left. Then, I'll divide both sides of the equation with negative 144 so I can get a value of x. Just to make it clear, because I began by finding a common point along all three circles at the same time, the value we get will be similar regardless of whichever equation we substituted back in. So I decided to substitute the value of into equation 4 because it has a simpler form, such that my equation now reads out as negative 12 times 5 minus negative 6y plus 72 equals to 0. I'm going to simplify it so that the negative 12 and 5 become negative 60. Then I'm going to combine like terms, which are negative 60 and positive 72. And finally, apply the same process of transposition by transferring negative 12 to the right-hand side of the equation and dividing it all by negative 6. That way, the value of y that I will get will also be a common point. Putting everything together, the location of our suspect is 5 kilometers east because we have a positive x value and 2 kilometers north for the same reason. I'd like to give a shout out to Mrs. Adela for helping me double check my solutions in this problem. Also, I'd like to acknowledge St. Anthony's School for providing me a location to do my recording. And to all those I bugged to critique my first video, thank you very much. If you like what you saw, don't forget to subscribe to help the channel grow. You can leave any curiosities or suggestions as well in the comments below. Any questions? Good.